The shift to cloud native architecture in mobile core networks is key to positioning CSPs for the requirements of an emerging 5G business landscape. Today, we're going to delve into the immense potential and the challenges of this transformational shift with Udayan Mukherjee, Intel Senior Fellow, 5G Network Architecture, Network and Edge Group, and Manish Singh, CTO of Telecom System Business at Dell Technologies. Welcome to you both. So, Manish, let's start with you. Can you briefly explain the concept of a cloud native architecture for the mobile core and how it differs from the legacy core in terms of flexibility and agility in the network?
Yeah, thank you, Clarence. First of all, thanks for having us. Great to be here. We are actually at a very interesting point in terms of the 5G evolution. While a lot of the 5G networks were getting initially rolled out, a lot of the focus was on the access side. But now a number of service providers are migrating their core networks towards standalone architectures. And this starts to create the perfect opportunity for them to introduce cloud native infrastructure and bring the core networks as cloud native functions onto that infrastructure. And how that's different from the past is, in the past, these core networks had been built with purpose-built appliances, single function, hardware, software, all very tightly integrated. And what that meant was much slower innovation cycles, very, very inflexible networks, and more. And while we've seen a lot of the transformation of cloud native technologies in the IT enterprise world and the benefits that number of industry verticals have derived from that. Now is the perfect opportunity for service providers as they migrate their core networks to SA to really take advantage of all the cloud native principles, which really comes down to scalability, agility, faster innovation cycles, much rapid CI/CD principles that they can really start to introduce to do continuous integration, continuous delivery, continuous testing, and more. And then I would also say that this also creates the opportunity for service providers to really think about introducing horizontal platforms and the infrastructure underpinning the workloads. And what that gives them then is the flexibility also to think from a network architecture perspective, newer variables that they can really tap into. I'll give you one example. We know a number of service providers today are facing video as the fastest growing traffic on their networks. And some of them are thinking about, can they have more distributed user plane functions, more out and about to handle this video traffic more effectively, maybe even with the caching functions being distributed more further out. So when you think about from a cloud native architecture and cloud native infrastructure, it also starts to give these kind of flexibilities to the service providers in terms of network workload function placements and more architectural flexibility to really deliver the needs of the traffic that they need to deliver while improve customer experience and optimize and lower the TCO.
And Udayan, do you have any further comments to add?
Yeah, I mean, building on that, what Manish said, the whole architecture actually evolved. So it is we call it a service-based architecture. So if you're the previous generation LTE and others, it's a monolithic elements of MME and the gateways. Now, even some of the control panel function like AMF, SMF, this has become like 20, 30, 40 microservices stitched together. So that's actually the first entry point of the cloud native technologies that our data centers have been using for a while now. So this is how the architectures evolved: very modular, scalable, scale out architecture, not monolithic. And then this actually is very easier now to actually introduce new services. Things like, for example, in industrial cases, time-sensitive network and others. So you can have an application function called AF introduced into that mix. So this is the first entry point for a lot of the services that we are talking more and more in 5G advanced and maybe even in next G. But the pinnacle of this thing is essentially the packet core. And this is where the service-based architecture of the cloud native principles have been introduced in 5G, which is what the operators are actually implementing now.
How are Dell and Intel investing in this new open network, and what are the key strategies to support the deployment of a cloud native architecture in telecom? Udayan, let's get Intel's take first.
Yeah, so what we have done essentially, so if you think of the cloud native, I mean, well, you can have still the implementation is the bare metal. It can be virtual functions. It can be containers. So we have an optimized stack into all of these elements of it so that we can showcase how we actually implement this. So these are the stack, whether it's a user plane, UPF, or control plane aspects to show how the systems can be scaled, what will it take to optimize on a general purpose processing silicon. So that's the first element of it. You have to help operators and the telecom equipment manufacturers to see, I mean, they're not being used to these cloud native principles before. How does this work? And the second aspect of it is sustainability. Now that you actually ready most software, you still have to make sure that your power consumption, the power that you draw from this is actually meeting the existing and requirements. The TCO has to be good. So a lot of sustainability to be built on a lot of this power management aspects of it. We have just had a software that was released called IPM, and for that matter, there's a public paper that one of the operator, SK Telecom, wrote with us, is publicly available now to showcase that how a cloud native architecture can be implemented and how you will actually improve power. And, with cloud native principles, what the traditionally our data centers have done long time is actually very aggressively power managed, the processing resources based on the load. So you can actually implement many of those in packet core. And we have implemented many of this to showcase what is possible.
And Manish, what are Dell's key strategies to support this deployment?
Yeah, absolutely. I mean, just building on what Udayan said, I mean, for Dell, obviously, everything for us starts at the compute layer, and we have extended our PowerEdge server product line, first of all, with our 16G server portfolio, built very much designed to, again, enable these cloud native network functions, which, as Udayan said, are microservices based and more. What we've also then done is work with a number of our CAS partners, with Wind River and Red Hat, where what we've done is taken the CAS solutions along with our servers and the automation, the bare metal orchestration. And what we've done is done all the engineering and integration heavy lifting, thereby introducing what we call as Dell Telecom infrastructure blocks, pre-integrated to the service providers. And these, we've, as I said, have created with Red Hat as well as Wind River, very, very well suited for the cloud native core deployment of the workloads. And what that does is it, again, helps the service providers to really accelerate their roadmap and not have to deal with some of the integration work that comes around it. The other thing that we have done is at Dell, we have invested in our lab capabilities, our open telecom ecosystem lab, which is where we've put in the right kind of cloud native infrastructure underpinning the CI/CD pipeline. And we're working with an open telecom ecosystem with our partners. We're bringing in the workloads and doing that integration and validation of the workloads on this cloud native infrastructure blocks. And not do that once, but do it on a continuous basis, leveraging the CI/CD principles, again, with the goal to bring that agility, that scalability, that flexibility that a cloud native architecture brings, and bring that to the service providers on a continuous basis.
And coming back to you, Manish, what are the tangible benefits for operators who choose to upgrade their core network to this new model?
There are a number of benefits. I mean, first and foremost, if we just think from a infrastructure provisioning and utilization perspective, we know that telecom infrastructure gets dimensioned for peak traffic. And if you look at the legacy architectures, which were monolithic, purpose-built, appliances, when you dimension and deploy the network for peak traffic, you are over provisioning the infrastructure in place. And in turn, the utilization rates of that infrastructure is very low. Secondly, the energy consumption of that infrastructure is much higher. So there are implications both on the CapEx as well as on the OpEx side. When you really start to migrate towards a cloud native architecture, that starts to give the benefit where you can really have a horizontal cloud platform, cutting actually all the way from your OSS, BSS functions to core networks, down to even on the access side with Open RAN. And with that horizontal infrastructure, you now have the ability to really optimize the infrastructure to meet the traffic needs. And again, take benefits of scale out architectures of the cloud native, which then means as your traffic grows, you can bring in more and more compute capabilities as needed. So there is, I mean, if you really think from a TCO perspective, there is obviously, first of all, on the infrastructure side, there are benefits to be had. And then Udayan just talked about some of the, sustainability, energy efficiency aspects. So, one of the things we are doing is, again, providing a lot of the telemetry data out of the servers to, again, give the visibility to the workloads to take advantage of either turning on, different states of the underlying compute silicon, for whether you clock it down, you turn off some cores, reduce the fan speeds and more, and thereby really optimize the energy consumption based on what the traffic needs are. So, I mean, if you really think about the vision, I mean, zero traffic, zero watt, I mean, we know we're never likely going to get there. But if you think about that from an end goal perspective, there's a whole lot of opportunity, again, on the energy and sustainability side, as well as, overall optimizing the TCO. And not to forget then the innovation side in terms of, the service agility. Again, we talked about the microservices-based architecture, ability to introduce newer functions, new capabilities, and bring that agility, that innovation onto the networks.
And Udayan, what benefits is Intel seeing here?
Yeah, I mean, if you look into what is the cloud native principles or cloud architecture, is essentially a set of resources that you actually consume based on your need. And I think building on what Manish was saying, traditionally for the generations, our telecom equipments were actually designed for the peak when you're in appliances. You don't have to. It's a set of compute resources, set of IO resources, set of storage resources. So this aggregation architecture, which is actually packet core was the first one. We refer Open RAN. Open RAN also it's gone into now in the cloud native principle, but packet core was the first elements that was addressed. And this scalability and resource optimization, resource utilization, and spending whatever the only resources that you need, and thereby saving power, sustainability. Those are key principles of cloud that is actually beneficial for the TCO. At the end of the day, is the bottom line is total cost of ownership. So that's where it actually adds to this. And the second one is more important than what ultimately the goal of 5G or even in future in XG is not just providing that EMBB or enhanced mobile broadband services that you and I am talking and elements, but additional services can be introduced and monetized. That's what the operators want. And this architecture, because of the microservice-based, service-based, it is easier to introduce new functions. We call there's a mode called application functions. So I gave a TSN example. Video can be an example. Deep packet inspections, doing some lawful intercept, many other stuff, can be built on top of it. In fact, if you see what's being discussed in our next G, the advanced architecture groups, is all about how do you bring more and more compute in the communication plane? So how do you actually add services and monetize it? So this is first and very important step towards that 5G has done on the packet core side of it, as well as on the radio access network side now.
We've discussed the benefits. What are the main challenges that telcos face when they're transitioning from a legacy core to a cloud native architecture in the mobile core? How are Intel and Dell helping to address these challenges? And Udayan, let's come to you first.
Yeah, there are challenges because for years of the architecture, there's a major shift in service-based architecture in 5G. So what's happening if you look in the industry? Operators are becoming very smart that way. So they have this, the architecture is kind of something called dual mode stack. So service-based architecture, but if you're growing, introducing your 5G as well as the 4G, you don't have to parallel stack running on those. So what is they're doing now is a dual mode, that non-service based architecture, the interfaces are get actually, there's a shim layer, and then under and behind that is the same stack. So think of that as I'll give an example, an MME in 4G and say an AMF in 5G. With a dual mode stack is the same implementation, but at the front it has turned into a service based architecture, and interfaces are actually evolved. So I think those are the aspects that Intel is showing how it can be done, and optimizing it on general purpose process silicon. Something that also Manish talked about. We are also working with CAS and PAS vendors, because this thing has to be orchestrated to examples like Red Hat, right, WinRiver, like others, like VMware. So these elements of these things, we are also optimizing it, testing it out. So showcasing what can be done. So that's the first element of it. And the other thing that Intel does very well is silicon side of it. So I talked all about software, but silicon has also evolved. More number of cores, there are instructions, elements to actually help in packet processing, in open line and signal processing. And so there are a lot of silicon innovations and scale out of the multi-core architecture that we're coming up with to actually increase the data throughput with the same power footprint, so thereby actually improving the overall TCO of the solution.
And Manish, how is Dell addressing these challenges?
Yeah, I mean, look, there are a number of challenges, but let me just take three. The first one, let's start with to really take advantage of a horizontal cloud infrastructure and all the efficiencies that come with it in terms of, infrastructure provisioning to infrastructure utilization and more. You really need to get the workloads to work on that horizontal infrastructure. And if we look at from the world of NFV, where we are coming from, many of these efforts, even in 4G when they got initiated, what the service providers ended up with, while it was virtualized, it was siloed implementations. And that's not good, because that's never going to deliver the efficiencies and benefits of a cloud native architecture. So one of the first challenges I would say is, when you even think from a core network and IMS network functions perspective, to make sure that you have the workloads, the network functions being ready on a horizontal cloud infrastructure that service provider wants to enable. The second challenge I would say is around integration. Integration of, again, bringing those workloads, those network functions onto that cloud native infrastructure. And this is where the world shifts from how things have been done in the past to what the future holds, where a lot of the service providers have sourced these core network functions and equipment from single vendor or a couple of vendors, and those vendors have been held responsible for delivering the SLAs. In the cloud native world, where you have your own private telco cloud infrastructure and you're bringing those network functions, that integration has to be done, and the service providers, along with SIs, have to build that muscle, that capability to really, again, bring those network functions, do that integration. Udayan talked about orchestration. So there is southbound integration, then there is northbound integration, really sets the solution end to end to deliver the kind of services that they want. So that's the second. And last but not the least, again, if you think from skill transformation, workforce transformation, to process transformation, to procurement, this starts to really change. It's a paradigm shift for the service providers, because the way you would source the equipment, to deploy it, to manage it, to optimize it on legacy monolithic network function based appliances is very different than the way you're going to source cloud native infrastructure, cloud native network functions, how you're going to integrate them, deploy them, manage them, and operate them. And that requires skill transformation. It actually requires process transformation. It requires procurement transformation and more. So there's a whole lot of organizational transformation also that the service providers have to undergo to really take the advantages of all the benefits that these cloud native architectures bring to them.
And Manish, can you discuss the importance of that vendor and developer ecosystem in deploying this type of architecture? How are Dell and Intel engaging with these ecosystems to drive innovation and deployment?
Yeah, I mean, I cannot overemphasize the importance of the ecosystem in itself. I mean, from Dell perspective, our approach is very much centered around an open, disaggregated telecom ecosystem. And as part of that, I mean, we have obviously taken our efforts to build what we call as our open telecom ecosystem community, which is really, it cuts across the stack, working with our silicon partners, to working with the CAS partners, to working with workload partners, orchestration partners, and more. And to facilitate the development of the ecosystem, we also then have put parallel investments in our labs in terms of our Open Telecom Ecosystem Lab, where think of it as putting all the required infrastructure and capabilities in place, bring the ecosystem in there, and do all that integration, validation of the solutions that's required, and then deliver those validated solutions, which are, again, truly open, disaggregated, cloud native to the service providers, and make it much more easier for the service providers to consume this open, disaggregated ecosystem and really benefit from all the cloud native principles and benefits that then come to them as part of this disaggregation and cloud native architectures.
And Udayan, what is Intel's view on ecosystem development?
Yeah, ecosystems is the most important part of this thing, because as you know, Intel doesn't sell the end product to the operators. We're not selling packet code. So ecosystems are actually most important elements of it. So it is not just our traditional. We work closely. We expand it the ecosystem. So imagine where the ecosystem come into play. The actual packet core network solutions, the software. I mean, it's not just traditional Ericsson's, Nokia's, and Cisco's of the world, but we have a lot of new players coming, like CASA, NECs, Mavenir's, and many others. So you work closely with all of them to actually make sure that that the scaling of the software, the optimization of the software that happens on a general purpose processing multi-core platform. Okay, so that's actually the providers of UPF and SMF, AMF, the actual network functions. Now it has to also get deployed. So what are those? Some of the CAS, PaaS, the cloud orchestration vendors and elements, things like WindRiver, Red Hat, VMware, and others. So we work closely with them to actually showcase how it actually can be deployed at scale horizontally into the platforms. And then obviously also that the hardware side as well, multiple different ODM, OEMs, and telecom equipment manufacturers that we work closely to actually expand the marketplace. So this has been this open platform definitions is actually opening up a lot more players, newer players, not only in the packet core, but also who even thought that in RAN, radio access network, you'll have newer players. So that's what is happening, and Intel is actually fully supporting and behind this.
So, how can telcos future-proof their core networks to avoid the need for further infrastructure changes? What are the key considerations that should be taken into account? Udayan, let's come to you first.
Okay, even in the next generation after 5G, whatever that comes in a 6G or next G, the number one elements is we're talking about is the cloud native architecture, and essentially the packet core has become a forefront of it. We have already converted in 5G most of those elements in service-based architecture. There are like a couple of interfaces like N1 and N2 still needs to be done. But this is already, future-proofing what is coming. It's more towards cloud, more towards services, more to a microservice-based architecture. The first step has already been taken on this. So, and then the other things we to do is essentially the similar architecture elements needs to go in the in the RAN radio access network. The service-based architecture is not there yet, although we are implementing cloud principles and orchestrations and containerization of RAN, but the service-based architecture is what we'll be discussing in the next G element of it, even in the RAN space. But packet core has taken that step in 5G, so it's very easily scaled. We need to constantly work with this and broaden the ecosystems, make it the way that the cloud, literally, this is, as I said, this is a set of resources. Think of that, a set of processing resource, a storage resource, memory resource, and how a software being implemented on this. Nothing different there. So that's the first step has already been taken. But we are constantly working with them to actually remove some of the pain point, improving the TCOs and the viability of the architecture, and we'll continue doing that.
And Manish, what are the considerations to avoid further infrastructure changes from your point of view?
Yeah, number of them, but again, I'm going to probably pick two or three. First and foremost, I would say think horizontal telco cloud, not silos, because if the implementations are done in silos, the service providers are not going to really reap the benefit, neither in terms of infrastructure optimization nor utilization. Rather, in turn, it's going to become more complex and challenging for them to handle. So really, really think about horizontal infrastructure. Secondly, think infrastructure automation first, right from the get-go. That's absolutely important, whether you're thinking about from a bare metal orchestration and automation perspective or automation with the CAS layers and more. That is absolutely essential. Even if you think automation from an energy efficiency, sustainability perspective, again, a lot of the capabilities are coming from now, the underlying infrastructure, but have that automation first mindset. That's absolutely clear. Number three, I would say keep an eye on where the puck's going to be. We are starting with a lot of this cloud native work in the core, but RAN's getting cloudified, RAN's getting disaggregated, RAN's getting open, and edge coming into focus. So when I say think about end-to-end horizontal infrastructure, keep those things in mind. Does your infrastructure scale and will meet the needs of those RAN workloads, those edge capabilities? Can it bring in even third-party workloads and more? And what capabilities do you need? And last but not the least, think AI and machine learning. That's the future. Do you have the right kind of compute resources in place? Do you have the right kind of storage resources in place? Are you capturing the right kind of data? And then how are you going to unlock the potential of AI and machine learning, really unlock the value of that data, whether it's in closed loop automation, whether that's in, traffic management and infrastructure optimization, and more. So there's a whole host of opportunities right there, but keep that front and center as you start to think about your cloud native infrastructure that you develop today and start how do you future proof for things that are coming down the road.
Manish and Udayan, thank you very much for your insights today.
Thank you. Thank you for having us.
Thank you. I really enjoyed it. Thank you.